thing we're going to be doing in this chapter is working with organizing and describing data. And what, as a consumer, as a person living in this world, and having to buy things, sell things, maybe where you work, whatever you do, just reading a newspaper, reading a magazine, oftentimes data is displayed in a visual form rather than just as numbers, okay? So we're going to first deal with where we have, does anybody know what kind of visual we have here for this recreation center enrollment? What do we call that? Bar graph. That's a bar graph. In fact, it's even a little bit more specific. It's a double bar graph because there are residents and non-residents that we're comparing for each of the activities, swimming, music, soccer, and dance. So we're comparing in each category, we have the residents and the non-residents, so it's made into a double bar graph, okay? So, and it shows that right here, it says comparisons between the two groups. So when we have comparisons between two groups, and you have to decide what kind of a data display to make, maybe a double bar graph would be a good display for you to choose. Okay, let's answer these questions. Which class shows the greatest difference between residents and non-residents? Now, first of all, the residents are represented by which bar? The white or the black? The residents.
White.
The white. This is what we call down here our key. This will tell us how to read the graph. Graphs typically have a key so that you know how to read them. So the residents are the white bars, and the non-residents are the black bars, or the filled-in ones. So it says, which class shows the greatest difference between residents and non-residents? They suggest here that we compare the bars for each class, and then choose the bars with the greatest difference. So we have swimming class, music class, soccer class, and dance class. Which one appears, just by looking at it, to have the greatest difference between the residents and non-residents? It looks like it could be dance, doesn't it? Okay, so because the white bar is quite a bit higher than the black one. Okay, so choose the bars with the greatest difference. We're going to say that it is dance, but then we're going to support our answer. Okay, so let's figure out how many. What was that difference? So how many residents were enrolled in dance?
250.
250. When we follow that over, when we follow this over, we see, oh, it's at the 250 mark. So 250. And then how many residents were enrolled in the dance class? We follow that over and we see it is 100. So 250 take away 100, 150. Do you think any of the others, we want to make sure we have the one with the greatest difference. Do you think any of the others have a bigger number than that? A difference bigger than that? No. It appears that the difference in soccer is what? Can you tell me? How many people?
50.
50. There's a difference of 50 people. In music, about how much?
5.
Okay, look at the scale over here. It's going by 50s. So between two lines, it's 50.
Oh, so like 20.
Maybe 10 or 20, yeah. Okay. How about swimming?
Like 130.
75.
It's 125. Take away 50, 75. So it looks like we have the one that has the greatest difference, the dance. Okay. Then it says, how many more people were enrolled in soccer than dance? Okay, well, notice it says how many more people. Does it say residents or non-residents?
No.
No. So Garcia, what are we going to have to do?
We're going to have to add up the number. Like we're going to have to add up the total people that play soccer and then the total people that play dance.
Yeah. We're going to have to figure out how many total were enrolled in the soccer classes, and then what's the total that were enrolled in dance, and then we can do our subtraction problem. So what are we going to add together for our soccer? What are our two numbers going to be?
303.
Yeah, 300. That's the residents, and then there were, it looks like 350 residents. So that, or non-residents, I mean. So that would be 650 enrolled in soccer class altogether. And this is the kind of work you're gonna need to show to support your answers on your homework. Notice which row I'm zeroing in on over here. And the total for dance, what are we gonna do there?
You're gonna add 100 and 250.
Okay, we got 250 for the residents and we have 100 for the non-residents, so altogether there are 350 enrolled in dance class. And the question was how many more people were enrolled in soccer than dance? So soccer, add or subtract? Subtract, how many more? Not how many total were enrolled in soccer and dance, how many more were enrolled in soccer than dance? So our answer is 300. Okay. Okay, so bar graphs. Pretty easy to read, aren't they? Okay, then let's go to a double line graph. When you have a double line graph, that's what a double line graph is really good for, is to easily see how groups change over time. When you think line graph, you want to think of over time. We connect things and we, notice there's spaces between the soccer, the dance, the music classes. That's discrete data. Sometimes our data isn't discrete. So what we want to do is we want to be able to see how it changes over time. We make it continuous kind of. So during which months were the number of male instructors equal to the number of female instructors? Well, first of all, it'd be good to know, how are we going to read this graph? How are we going to know which line?
Those squares on is female, the one with triangles on it is male.
Okay, so we have to zero in and say wherever we see the lines that have the little squares on them, those are the females, and the ones that have the triangles, that represents the males. Okay, so the first question they asked is during which month or months were the number of male instructors equal to the number of female instructors? It says look for where the data points overlap. So which month or months do you think we can claim that there were equal amounts of each? March? Okay, March would be right here. This is March.
No, February, like mid-February. No, February.
May.
Okay, here's February.
Like
Right here.
May.
Are they on top of each other, those points?
January.
Oh, January, look at here in January. They're really actually on top of each other because there's only one there.
It's
So
May
that-
too.
And May.
And so January, and then is there another month you saying?
May.
Yeah.
Okay, in April, are they on top of each other?
No.
No, but in May they are on top of each
Oh,
other.
yeah, May, that's right.
So
And then-
January and May, do we have any other months that the data points are on top of each other? No, they're either above or below each other, aren't they? So we have, in January and May, the instructors were equal between the two genders. And then it says between what two consecutive months did the number of female instructors increase the most? Do we even have to look at the ones with the triangles on? No, we only want to look at between the squares. We want to see where is the steepest slope.
January,
Or I mean
May,
June.
March.
From month, which month to which month?
From March to June.
Okay, now, it should really only be from 1 month to, between what two consecutive months? What does consecutive mean? They follow each other. So like Monday and Tuesday are consecutive days. What would be consecutive months?
January, February.
January, February, August, September. So between which two consecutive months do you think the number of female instructors increased the most? Which line segment that has squares on it
April and May.
No.
is steepest?
Or steepest, I thought.
Steepest,
February, March.
Yeah.
okay? So we're talking about right here, from here to here?
Yeah.
Okay, okay, because here's definitely is steeper than this one, right? Definitely steeper than that, and that's a decrease. They wanted an increase. We don't even have to look at those. We can look at this one. Is that one as steep as that one? No. There's a decrease again. There's no change. There's a decrease. Here's an increase, is that one as steep as the green one?
No.
No. And we don't have any other increases, so we're gonna have to go with between February and March, right? We decided? After February, the first M is for March. Okay, so from February to March. Okay, I'm just curious, could you tell me, was there ever a time in the female instructor's data that there was no change? From any month consecutive between
Yeah,
consecutive
that's what I
months?
thought you meant, January and August,
June, July, and August.
July, whatever,
Okay, so from here to here, that's
Well,
July
that's
to, from July to August,
and October and November.
and from October to November, there was no change, was there? Was there ever a time in the male instructors that there was no change?
No.
No, it's always changing.
It's always changing, yeah, the male instructor, the amount of them is always changing, so, okay. Okay, let's look at the bar graph that we have here now. They're gonna have us practice a bar graph one a little bit more. So why don't you go ahead and answer those questions and show some work to support your answers for 5, 6, and 7. So get yourself acquainted with the graph, what's being represented on it. So if you're reading it to yourself.
For number 7, they say or.
So that means together,
Okay, that's what I thought.
put the two together. And again, whenever you have to come up with a numerical value that you had to do some adding or subtracting, show what you actually added or show what you actually subtracted, or the numbers you had to use. Okay, so for number 5, which method of transportation is used most by students and how can you tell?
Carpool.
Carpool. I bet that, do you think that's true in Valley City?
No.
No. So how can we tell that it's carpool without even having to do any?
It's just.
Both bars for those are higher than any of the bars there, right? Both the boys and the males and the females. So it is cut and dried, it is carpool. Okay, that must be somewhere where they have traffic and they don't want to have to deal with that many cars. How many more girls than boys walk to school? So we just zero in on the walking, right? How many more boys than girls? How many more girls than boys walk to school? How many girls walk to school? 9. And then if we want to know how many more, do we add or subtract? Subtract. And then how many girls walk to school? 5. So every grid line is 2, so halfway between would be 1 student, wouldn't it? So 9 take away 5, what would we say? 4. There are 4 more girls than there are boys who walk to school. Okay, how many more boys go by car or ride in a carpool?
You have to add the carpool and the car together for both the
It
boys.
doesn't say how many more, I'm sorry, I said that wrong. How many boys, just boys, go by car or ride in a carpool and you have to add them together? Okay, so how many boys go by car?
10.
10, the white bars. And how many go in a carpool? 12. So altogether there are 22 boys who ride in or walk or carpool. Okay. So any questions about that one? Okay, let's look at circle graphs. I'm not going to make you make any circle graphs because then you'd have to have a compass and protractors and all kinds of stuff like that. But we have to understand how to read them and what they're good for. First of all, circle graphs are good for when you want to compare data to a whole set of it. You wanna say, this is like, there are this many boys out of a total group of people at the concert, let's say. And this one is a monthly budget. They're saying that 10% got spent on entertainment. That's how much they're allowing to be spent on entertainment, I should say. They're going to allow how much for college? Is that what that says, it's college?
Yeah.
Okay, how much money are they putting aside for the college fund? 20%. Okay, so does that mean $20?
No.
No, we don't know how much their money they have to spend for the month, do we? Which category accounts for the highest percentage of the monthly budget?
Savings.
Savings, and how can we tell just by looking at just the circle graph?
Because it's 40%.
Because it's 40%, and what else?
It's the highest one, the biggest chunk on it.
It's the biggest chunk of, if you got, that was a pizza cut up, and you took the savings piece, would you get the biggest piece?
Yeah.
Yeah. Okay, so we have savings. 40% of their monthly budget is saved. Wow, that's a lot of money. Which categories account for the smallest percentage of the monthly budget?
Entertainment and clothing.
Entertainment and clothing, they both are 10%, aren't they? Okay, entertainment and clothing, each of them account for 10% of the budget. So now they say if their budget is $500, how much is spent on food? How much? Doesn't say what percent. So we would have to do what? Food is what percent? 20%. Okay, so we have to find out what is 20% of $500. That's what we're actually looking for, right? Okay, so we can change it to a decimal, or we can change it to a fraction, either or. What is its decimal name? 0.2. What's its fraction name? 20 is what part of 100? 1/5.
Yeah.
Oh, goodness sakes. So we could take 0.2 times 500, or we could take 1/5 times 500, and either way, our answer is what? $100. Yeah. And we have work to support it, okay? And we have work to support it. Should not have been a question we could not answer, that 20% is 1/5. That's scary, I can't let you guys out of high school, I guess. Okay. So, let's go to the back side and do some more practicing, or actually, no, we have to talk about what kind of data, what kind of display should we make given the type of data that we have. So, if the data is organized into categories, they suggest we use a bar graph, or if there's a couple of things that we need to compare, then a double bar graph. If it's something that changes over a period of time, then you want to go with a line graph. Unless there's two things that are being compared, you'd make it a double line graph. If you want to compare categories to a whole set, like a whole monthly budget, then you want to work with a circle graph. So in this first one they say, use the data at the right to make a graph. Well, that's making a circle graph, and what did I say I'm not going to make you do? I'm not going to make you make circle graphs, but we do have, what I am going to make you do is I am going to have you figure out what percent it would be. Okay, so as if you were going to make a circle graph, then you could say, okay, this would be this percentage of the whole. So notice what's the first thing we have to do. If we want to compare the whole, this is recipe for bubbles. And here are all of the ingredients. We have bubble soap, dishwashing liquid, glycerin, and water. So what we're going to do is we're going to figure out what percent of the recipe is bubble soap. What percent of the recipe is dishwashing liquid, and so on. So first thing we got to do is we got to add all those numbers up so we know what the total is. What's the total amount in the recipe? There's 20 cups altogether. So then, when we do percent, it's just like when you take that quiz, upstairs is the part, and downstairs is the whole. What was the part? What did you get right on the quiz out of the whole number of points you could have gotten? Same thing here. Bubble soap, there's 8 cups in the recipe, There's 20 cups altogether, so 8 divided by 20, changed to a percent, is 40%. Okay, now if we were making a circle graph, this is what we would have to do. We'd have to multiply it by, how many degrees are there in a whole circle?
100.
No,
360.
360. So we would take 40% of 360 and say, oh, the angle that we need for the bubble part would have to be a 144-degree angle. This right here would have to be 144 degrees if we were going to actually make the circle graph. Okay, but we're not going to make it. Okay, well, let's do what we're going to do when we get to the circle graph here. First thing we're going to do here is write bar, double bar, line, double line, or circle to indicate the type of graph that we should use to display the data. Doesn't say we have to make it, just says we have to figure out what kind. So number one, if we were going to compare the math, if we wanted to display the math scores of one student over the school year,
Be a line
it would be a line graph, because why?
Because it's over time period.
Because it's over time, it's over a year of time. So math scores of a student over a year, would it have to be a double line graph?
No.
No, just a line graph. Garcia, join us. Number two, attendance at an exercise class by age group as it relates to total attendance. So in other words, they got this exercise class and there's maybe an age group, they say, okay, if you're 16 and under, you're in this class. If you're 17 through 30, you're in that class. If you're 31 through 50, you're in this class. If you're over 50, you're in another class. What kind of a graph should we do for that one, do you think? What's going on here? Attendance at an exercise class by age group as it relates to total attendance. Here's the key word right here. Go back and look at what they said about circle graphs at the top. What they say about circle graphs up at the top?
Compare categories to a whole set.
To a whole set. So it's kind of like whole is total. So this would actually be a good circle graph. Because we want to compare it to the whole. Now, if they would have said attendance at an exercise class by age group, then we could have just done a bar graph. But they want it to relate to, as it relates to total attendance. They wanted to show how big of a part do they have out of the whole? Which class is the biggest, in other words, out of the whole class? Number three, the number of animals seen in a farm.
Bar graph.
There would be our bar graph. We'd have a bar for the number of cows. We'd have the bar for the number of pigs. We'd have a bar for the number of chickens. This one doesn't say anything about comparing it to the whole, so this would be a good one that we would do a bar graph for. And then it says, a store owner uses an entire wall to display toys as shown in the table. Determine the percent of each toy for sale. In other words, apparently wants to make a circle graph with this. So let's practice how we would do that. Okay, what's the first thing we need to do?
Add them all up.
Add them all up. We need 10 plus 5 plus 3 plus 2 to see how many total shelves are going to get used. Okay, so how many shelves are there? 20. Okay, so we have 20 shelves altogether. Okay, they're going to put games on 10 of the shelves. So let's start with games. Games are going to go on 10 shelves out of the 20, so what percentage is that? 50%. 50%. That's a half, and we know that that is 50%. Half of 100% is 50%. Okay, then let's do puzzles. 5 over 20, which is the same as what fraction? 1/4, and we know that 1/4 is 25%. Okay, and this is how you would show your work in your homework for these. Dolls, what are you going to start with? 3 divided by 100? 3 over 20. Oh, that one doesn't simplify as a fraction, but here's a nice little trick. If you can multiply the bottom by something that will give you 100, what can you take?
Or 5.
20 can, let's see, 20 can get multiplied by 5. And so if we multiply downstairs by 5, we multiply the upstairs, so we end up with 15 over 100. So what percent is that? 15%. Out of 100, that's what percent means. 15 out of 100, 15%. And last but not least, our trains.
Okay.
We have 2 out of 20, which is 1/10, which is 10%. That's a pretty easy one to do also with the fraction. Okay, what should be true about our percents?
They show that.
You better add it to 100, you better make a whole circle, right? So 50 plus 25, 75 plus 15, 75 plus 15,
80.
75 plus 15.
Start at the bottom. It works
90
easier.
and add 10. Oh, rises are a bit easier to go from the bottom. 10 plus 15?
25.
25, 25 plus 25?
50.
50 plus 50? Oh, you're so smart, right?
Yep.
Okay, so that's what you will be doing in this lesson.